Hello, I'm Remy. We did our project on electron geometry and Lewis structures. For my worksheet, I explained that electron pair geometries are described by the regions of the electrons and where they're located on the molecule. And then for molecular structure, I described the location of the atoms, and it's not with the electrons. So for the shape, all bonds count as one, which would be single, double, and triple. They all count as one bond when looking at the shape of the molecule. And then we just put a graph with the electron pair geometries and how to determine the molecular structure based on the lone pairs, which would be these tiers here. I also included a picture of lone pairs, which would be this balloon-shaped, plus the molecular structure, and that would equal the electron geometry pair. And then in the back, I put a graph so that people could practice with H2O, NH3, CO2, and CH4. And then they'd be able to tell us the molecular structure, electron pair geometry, draw a diagram, tell the angle of the shape, how many bonding pairs, and how many lone pairs. And that's it for my worksheet.
I'm Sophia and I did drawing Lewis structures. So for my worksheet, basically I just had it nice and simple. I had the definition, some exceptions to the rule like hydrogen and boron, their octet is like 2 and 6. I also have a picture inserted here so you can easily see how many electrons are with what element, especially nonmetals. And then on the bottom I have examples of, single, double, triple bonds and some steps for how to draw them out. On the back of the worksheet, I broke it down. One example of H2N1 with a negative 2 CO3 negative 2. So you get a feel for that. And on the bottom is just some examples for you to practice on your own.
And then for our activity, we played trash-ball. So we had 2 volunteers from each side of the classroom, which we split in half. We had those 2 volunteers holding their arms out like a hoop, and then we crumbled up pieces of paper so that volunteers could shoot it, and it was basically a race between the 2 teams to see who could complete their row for their molecule the fastest, and whichever team won got a prize. And that's it for our project.